Start recording. Hello all, good evening to all of you. This is a belt exam week. I hope everyone is preparing good for the belt exam. And welcome back to Machine Learning Stack. Welcome to week 7, lecture 2, Data Science in Python and Machine Learning Coding Dojo. Announcements. All assignments due by Friday. If you are pending with any assignment from week 1, week 2, please submit it, or resubmission is also for the week 2 to be eligible for the belt exam. And set aside 8 to 12 hours this weekend for your exam. And in your exam, it will cover all material from week 1 to 3. So in the belt exam, your belt exam to be from December 2nd and December 4th. The students who are eligible, I will release the belt exam code on Friday morning as soon as possible. You need at least 8 hours to complete it, and don't be like to take attention. Just be relaxed and calm when you start your exam. The few tips before starting your exam, this is good. If you can do the practice for these two mock belt exam on the Learn platform. That is one exam for classification task and another is for regression task. So it will be very, very beneficial for you before starting your exam. And don't forget to follow the rubrics which is given on your feedback document under the belt exam tab 2. You need to follow all rubrics from there. If you follow those rubrics, you will not forget any step in the belt exam. So it is also the another, this is also good for you. And week 3 material will be on the exam. Check for rubric. This is I already told you. So these are the things you need to take care before sitting into the exam. Okay. And the students who are still did not submit the assignments or missing assignment from week 2, please submit those assignments to be eligible for the belt exam. Anybody have any confusion, any questions for the belt exam eligibility? All right. So this is your reading calendar for the next class, live class. You can go through this material. This is what is boosting, gradient boosting. And you can look at this schedule. Good, scroll down. Here you can see what you need to read before the next live class. Okay. Recap. In previous lesson, you have learned about the what are a classification matrix, what is a confusion matrix, and what is accuracy, recall, and precision. So this is very, very important. All these metrics. If you have any confusion, any questions regarding this, we can discuss it in office hours after the class. Okay. So before moving ahead to the 5-minute breakout room activity, I want to highlight the common mistake I found in many assignments, which I want to clear today so you don't repeat. I have seen in many assignments, like when you are splitting the data, right? Let's suppose you need to apply more than one model. So what I saw in the assignments, when you are separating the X and Y, right? And then you are using train, test, split method, right? I have seen in many assignments, you are repeating these 3 steps again and again for each model, which is not required at all. Okay. We always separate the features, X features and target only one time. The reason behind that, because you are going to work on the same data set. So you don't need to split it again and again. You have already did it first time. You can use the same X-train, Y-train, X-test, Y-test for the different models. So if there are extra steps, I ask them to resubmit the assignment. Please don't repeat these mistakes in future. If you have any confusion, please book 101, or you can also ping me on Discord or email me. Okay. Any confusion about this? Anyone? Why we don't need to like declare X and Y again and again? Any confusion? All right, take your time. Now we will do 5-minute breakout room activity. In this, you need to answer these two questions. That is, which among the following evaluation matrix would not use to measurement the performance of classification model? Okay. And what does the recall refer to in classification? I will open a breakout room for 5 minutes. All of you can attend this. Okay. Amal, you did not join? Hey, Justina.
Oh, hi. How you doing?
Good. How are you?
Good, good.
You
Sorry
want to
about that.
join room?
Um, I think it's already started, so I'll just stay here. It's okay. I'm still trying to catch up and understand a lot of this stuff, so I've caught up quite a bit. I've done some of the readings, so now I'm just trying to actually do the actual assignments and everything. So yeah, yeah. I missed you on Monday. I saw that you weren't teaching, so hopefully you are okay.
Yes, actually, my son was not well. That's why. It was an emergency. That's why I need to go to the hospital on that day.
Oh no. Yeah, hope everything is better now. I keep you in prayer.
Yeah. Thank you.
No problem, no problem. Um, yeah. So I'm gonna still some catching up to do. Definitely still some
Sure.
catching up to do.
Sure.
But at least I could kind of keep these, kind of keep up. So I'm much better than I was a couple weeks ago. So which is good.
Good.
But yeah.
Okay.
Um, so it says, what is a recall? First after classification. What is recall classification? Sometimes I feel like, oh wait, I'm recording. Never mind. I'm recording. Never mind. Oh, they won't catch me.
I'm looking at the answers. Classification matrix are good to go. Did you read that content?
No, not yet. Not yet.
Okay.
I'm still like on like, I won't say how weak I am now, but I'm catching up. I'm definitely catching up. I'm doing more of the readings. I'm definitely following along. And it's helpful for me to like still come
Yes.
to the lectures, because then when I do get to it, I'm like, oh, I remember what what you were saying, and then I'll be able to like go through the content a little bit more, but slowly but surely, slowly but surely.
Okay. So everybody is back. Let's look at the answers. So the first question was, what does recall refer to in classification? Not this one, sorry. First question was, which among the following evaluation matrix would you not use to measure the performance of classification? This is correct for MSCE because this is our regression matrix. We use it for regression model only. The thing is that the matrix which is for regression, that is only used for regression. The classification matrix is only used for classification model. Okay. Okay, the second question was, what does the recall refer to in classification? This is, okay, okay. The answer to this question is the first one, the proportion of all the relevant data points. Okay, okay, good participation. Anybody have any confusion in the precision and recall?
Not to be that guy, but the literal definition from the book is how many samples did our model label as positive out of all of the true positive samples? So how is the first one correct in that explanation? Because wouldn't it be the second one? Because you only want to look at the correct data points, because that's literally what
Yes.
the definition in the textbook says.
Yes. Okay. In this, the proportion of all the relevant data points means in recall, we are not looking at the positive data points which were actually positive. Okay.
Yeah.
Correct data point means which were actually positive and your machine is also predicted it as a positive. That's why that is the definition of your precision. And if we talk about the recall, in that we are counting the total positive points, the relevant total points positive predicted by the machine out of the total positive points. Okay. In that, if you are going to count it, right, how many total positive are predicted and how many were predicted incorrectly, false positive. Okay. So that is the definition of recall. Okay. Correct means which were actually positive and machine is also predicted it correctly. Does it make sense, Sam?
I mean, yes, I understand. I'm just saying, I the way it's written, it seems like B would be the correct answer, but that's okay.
Okay, so let's move ahead for today's lesson. Decision threshold and receiver operating character. That means like we are going to talk about today the balancing type 1 and type 2 error. Okay. So before moving ahead, I have a question for all of you. Anybody can tell me what is type 1 and type 2 error? Anyone? You did it in first lesson in classification.
A type 1 error is a false positive and a type 2 error is a false negative.
Correct. Good. So learning goals for today is your explain ROC-AUC and how it relates to the quality of the model, and your change the balance of false positive and false negative errors your model makes. Create a function to evaluate classification model. We are going to discuss these topics today. So first of all, we will discuss about when are false positive worse, in which cases, right? If you are getting any data set, right, it depends upon your business goal or the problem, which error is most expensive for you, right? The error which is most expensive for you, you are going to focus on that. We can't make sure if you are getting any data set, like for example, you are getting the data set of any disease, like the heart patient data set, right? This will be decided by the domain expertise, like on which error you are going to focus more. They may ask you to balance both errors, type 1, type 2 error. Maybe they will ask you, you only need to focus on type 1 error or either type 2 error. It depends upon totally the business problem. So in this, we are going to discuss about these problems when our false positive can be worse. False positive errors are those which are really not positive, but your machine is saying it's positive. So for example, hiring a bad fit employee. If we are saying like in true, I will take one example here of the employee. Okay. So let's suppose this is your first column, this is your second column. We are saying here the employee is not good, right? So we will say 0, right? But what your machine is predicting 1, right? In that case, what will happen? This is a false positive, which is going to be worse in this case, because this is going to be give you the false positive error here. In this, what will happen? You will hire, if you are employer, you are hiring a bad fit employee. In actual, right? We give the data to the machine. If this employee is not good, maybe the skill sets are not matching, experience is not matching with the job. Maybe he is not a good team player, right? So in that case, this is going to be like worse, right? If any company hire a bad employee or bad fit employee, what will happen? Company may go into the loss. He is a not good team player. Maybe other team members are not like doing good with him or her, and he is not or she is not very productive, right? So there are many things which mismatches. So in this case, you are worse. Okay. Firing a good employee. Maybe, right? We are saying don't fire the employee, but your machine is saying no, fire. So in this again, false positive is going to be worse, right? The third is predicting cancer. Harsh treatment in this case, right? As I have given an example earlier about the heart disease. In that case, your false positive may not be, we can say it depends, right? There are several tests in between, right? When we finalize this patient have a heart disease, right? But if we are talking about in cancer, this is a harsh treatment. If patient does not have a cancer, your machine is saying he has a cancer. So what will happen? In the next stage, in the next test, he is going to under chemotherapy, which is not required, right? The patient is taking the treatment which is not like required for him because he or she is okay. In that case, what will happen? False positive is worse. So you need to take care of these kind of things according to your business goal. But same problem, if we are talking about the heart disease, maybe first the normal test is going on. Second stage, at second stage, if machine is saying this patient have a heart disease, he is going under second stage. But this is not, we are going to give them the chemotherapy, right? In that case, it may be not so worse. But in this case, it is going to be worse. So I am giving you the two different examples in which you need to take care which type, where your false positive can be worse or maybe not. Predicting pregnancy. If we are giving the data set, right, your machine is saying man is pregnant, which is not possible at all, right? So this is depend upon your business problem and in which cases the false positive can be worse, how you can balance them, how you can make your model very good so your false positive can be reduced, right? So it depends how you are going to doing the analysis and how you are going to apply the metrics and decide which how your model is going to be work. Any other example you can think about where the false positive can be worse? Apart from this,
A failed drug test for an Olympic athlete when he didn't do drugs,
yes. Good,
wouldn't be
Sam.
able to compete.
Good. So when are a false negative can be worse. So these are the another example when your false negative can be worse, right? Your machine is not able to predict correctly your true negative, right? So in this first example, we will take the diagnose a deadly disease. Disease here can be heart disease, right? Sugar, cancer again, right? In that case, product recall. This is another example, right? Predicting natural disaster. In this, we don't know, right? If natural disaster means earthquake, maybe flood or any other thing, right? We are expecting it is not coming, but it is coming, right? So in that case, your false negative can be worse because we like have a great loss in that case. If your machine is not, model is not working good in that case. Self-driving car, identify a people in the road. If in this case, your machine is not detecting any obstacle on the road, what will happen, right? An accident will happen, right? In this case, your false negative can be worse. So these are the few very common examples, most common examples in which you need to take care of these type of error. Okay. Any other example you can give about the false negative? Anyone?
A meteor's gonna hit.
Daniel, can you repeat?
A meteor's gonna hit, like
Okay.
it says it's not gonna hit, but it actually is going to.
Okay. Good. We can also like think about stock predictions as well, right? In this case, although in stock prediction, we need to balance both things, right? False negative and your false positive as well. Right?
Also, when it comes to like safety protocols for like buildings, cars, and things that actually transport people, and if you're saying that it's safe but it's not, but this would be helpful. Yeah.
Okay, good, great. Okay, so now we will take one example. Based on that, we will discuss how you can balance your type 1 and type 2 error, right? And in the decision threshold, which we are going to discuss further, This is very, very useful because when you don't want to change the model, you want to use the same model, but you want to improve it, right? You want to classify the different classes more accurately. At that time, your decision threshold is very useful. So I'm going to take a one example here. That is, you are predicting heart disease. Okay. So positive class, we are saying if the patient have a heart disease. False positive, predict they get it, but no heart disease, right? This is incorrect positive, right? False negative means predict they don't get it, but they do. Your machine is saying no, they have. Okay. So which is a worse according to you in this case? If we have a business problem, heart disease, according to all of you, which error is going to be more expensive? False positive or false negative? Anyone? According to you, which error is more expensive, most expensive for you? Like on which error you will focus more?
False negative.
False negative.
Okay. Why?
I don't think there are harsh treatments like with heart disease. As opposed to like cancer, they're like really harsh. So like you really want to make sure like, hey, they have cancer, you know, make sure because the treatment could leave them worse than they were there. But with heart disease, certain medication, yes, to have like certain side effects, but I think that's more forgiving. So that's why I would think that if we gave someone heart disease medication, they probably won't die. Maybe have some side effects, but if I won't die, no costly effects with it. So that's my reasoning.
Okay. Anyone else? Okay. Okay, good, Justina. Like in this case, most probably, like if a few minutes ago I have given the example of heart disease, right? Like in that case, if because I was doing the comparison between the, yes, you said the same thing, because in case of cancer, it is going to be harsh treatment, right? But in case of heart disease, there are different stages for testing. But most probably, right, we always, when we are talking about the health domain, right, we are always like try to make our model in which we will focus on false positive error, right? In this, what like maybe if the patient have a disease, right, in real, but machine is saying no, he don't have a disease, right? We need to decrease it, right? If you want to balance both, that is also good in this case. It totally depends upon the domain expertise, what they are saying you, what is important for them, right? So it depends upon the situation as well, right? Okay, so before moving ahead, we will do poll. Good, good. Good. Okay, the correct answer to this question is an unequal. Okay, because the accuracy cannot give you the correct answer if your data set is imbalanced, right? Although you cannot rely on the single number in case of classification, because accuracy is going to give you a single number. You don't know how many positive or false positive, false negative, right? So whenever you are doing the classification like modeling, always use all metrics, right? So we have one more poll. Okay, this poll we do later on. Okay, so now we will talk about the model errors. Before moving ahead, I have a question. What are the model errors in classification and in regression? We did the model errors in regression as well, and we have discussed the model errors in classification as well. So what is the difference? Remember about the regression? What were the model errors?
Like underfitting and overfitting in regression?
Hmm. We were
Like-
doing this.
Like
Positive, negative error, bias and variance. Yes. Right? And what about the classification? Difference between both of them. The classification error and regression error. This is correct, Daniel. And what about the classification? You all know the answer. Okay, I will give you one example. If I am saying the patient have a heart disease, machine is saying no, the patient does not have a heart disease. So what is error? How would you define it in classification? When your actual value is not matching with the predicted one, right? This is your model error in classification. This is, but in regression, you were doing the actual minus predicted one, right? You were finding the errors in that, like that. In classification, this is very straightforward. If actual value is not matching with the predicted one, this is error, right? That's why you are getting false positive, false negative errors. Does it make sense? Okay. So now look at this. This is your confusion matrix, right? In this, these are your good numbers, which we want, right? According to your business problem, right now we have a business problem, heart disease, right? So we want to improve this one, right? In this true positive. And these are your bad numbers. We don't want these numbers. We always want to reduce it according to your business problem. In some cases, you want to reduce both. In some cases, you want to reduce only this one or maybe this one, right? In this, what I want to do, I want to say, like, if in actual, I have a patient have a heart disease, my machine should predict it correctly. It should not say no, it does not have, the patient does not have a heart disease. Okay, so I would like to reduce this one. Okay, in this heart disease. Okay, if you want to reduce both, nothing is wrong in that. Okay, now these are your errors in classification: false positive, false negative, right? So let's move ahead. Now look at this. So why we use a decision threshold, why we need it? When we are talking about the binary classification, right? So you are just predicting either it's a 0 or 1, right? So when you are getting the prediction value, you will get either 0 or 1. But when you are going to use the decision threshold value, we will set some cutoff value to classify your predictions as a in form of probability for each data point. Okay, so it will give you not the like 0, 1 result, but it will give you the result for each data point, probability of happening this one, the patient have a heart disease. Okay, practically how it will look like, you will see in the code along. Okay, now look at this example. So here, this is the distribution of your two classes, right? This is your negative class, the blue one. The green one is your positive one. So the positive class, we were assuming if the patient have a heart disease, right? We will call it true positive. If the patient does not have a heart disease, we call it true negative. Okay. Now, in Python, there is no automatic method to set up the threshold value. It's a manual method. Okay. And you can set the ranges between 0 and 1. Okay. You can set as many as value you want. 0.5, you can start with 0.5, 0.6, 0.3, 0.2, 0.1. This is your choice. But by default, the decision threshold value is 0.5. Okay. If you look at this, if I set up the 0.5, this value, so I will assume if my input, my true value is greater than 0.5, I will say the patient have heart disease. Okay. So this will be it will give me the probability of happening this patient have a heart disease, right? If value is greater than your cutoff value, decision threshold value. If the value is less than this, so my machine will say the patient does not have a disease. Okay. So if it is less than, true negative. Probability of happening this, true negative. If it is greater than, probability of happening, true positive. Okay. If you look at now in this, you can see false negative error and false positive error is coming almost equal, right? There is a very little difference between both of them, right? Errors. So in what I am trying to do, this is you can look at this decision threshold. This seems to be normal distribution of the data of both classes, right? So it's easy for us when I set up this is able to predict correctly most of the cases true positive and true negative, right? Now try to change the value of this one, the decision threshold. Now look at this. What is happening here? Earlier, your false negative, false positive seems to be okay, right? Errors. But when I decrease the decision threshold value, what is happening? Which error is increasing? Which error is decreasing? If you look at this picture, can you see which error is increasing or decreasing?
It looks like false negatives are decreasing, but false positives are increasing.
Great, Craig. Yes. Correct. Right? So what is happening? When I set up the decision threshold value, I was decreasing the value. My machine was not able to predict more correctly the cases of true positive. Right? It increases the error of your false positive. Right? And decreasing false negative. So in this case, what will happen? If false positive is most expensive for me, I will not use this cutoff value, right? Because my goal was to decrease this error, right? But if the most expensive for you, the false negative, then you can choose this value. Okay? It depends upon your situation. It depends upon your business problem. What error is most expensive for you. According to that, you will choose a cutoff or decision threshold value. You can run the loop with the different values. You can set up the range from 0.1 to 1 and see the difference and results. Okay, and then you can choose a final decision threshold value where you can see it is balancing and it is able to predict most of the cases correctly true positive, which is our goal, right? Any confusion till so far? Any confusion? Okay, take your time. If something come up in your mind, feel free to ask. So till so far, we have discussed about the decision threshold value. Why we use it, how to use it. You will again see it practically when we will do the code along. Okay. So decision threshold value is really good in cases of if your data set is balanced, right? If sometime your data set is not balanced, unbalanced, in that case, decision threshold will not work very good, right? Because its focus will be how much value you will be selecting that. It is going to be classify your one class more rather than the other, right? So if your data set is skewed, your distribution is skewed, you need to take care. Okay. Now we will look at the here ROC-AUC. Okay. So this is the most important visual effect which will show you the results of your model performance between your true positive rate, this one, and false positive rate, right? In this, it is only the visual effect, right? On different threshold values, okay? So we use it only to look at visually how your model is performing good in the sense of at different threshold value, right? If we go back here in our previous slide, can anybody tell me what is true positive rate? Anybody? What is true positive rate and false positive rate? Why we are only
The
looking at
percentage
this?
of true positives in whatever the results of the algorithm are.
Yes, and great answer. Okay, that's why when we are using the ROC, over focus is on the true positive rate against your false positive rate, right? False positive rate means which like type of your error, like for example, if actual value was 1 positive, machine is saying no. Sorry, your actual value was 0, machine is saying 1. This is your false positive rate, right? We are talking about here rate word because we are talking about the probability of happening that, right? Because we are using now decision threshold value. We are not talking about binary output. We are talking about the probability of happening each data point. It is going to be positive. It is going to be negative, right? If you look at these, visually, you can see the graphically like the percentage of your true positive rate and false positive rate. We are taking an example here, logistic regression, okay? And your baseline model with this one. So if you look at these, this line is your baseline model. This is the middle of your graph, right? If you look at this blue line, the true positive rate is higher here, right? So that's why its ROC value is 0.96, okay? And higher the true positive rate, best is the model. Because this is our goal. We want to find out more true positive value for over each model. This is our goal. Higher will be this rate, best is the model. And the area under this curve, this one, is known as AUC. We call it area under curve. Bigger the area is covered under this line, good or best is the model. Why? Because if you look at this on the y-axis, this is true positive rate, starting from here 0 and going to be 100%, right? So if this line is matching here, this means 96% your model was able to predict your value correctly. Its true positive rate is high, right? And this yellow line we are showing for the base model. If your baseline model is not working good, it's only showing the 50% of the model. So this means this is poor performer model, right? But logistic regression is doing good. It's doing best. 96% was able to predict correctly your true positive. Your true positive rate is very high, right? So much true positive rate higher means your precision and recall is high. Okay. And your area under curve is covered very good. In this case, your both precision and recall is higher. Okay. So that's why your model is good, best. Okay. It depends. Sometime you want the high precision, low recall. Sometime you want the low precision, high recall. It depends upon your business problem again. Okay. But right now, if you look at these, in this case, your precision and recall both are high. Okay. So this is, that's why we use the ROC-AUC to look visually the performance of the model of your classification model. More the true positive area under curve, best is the model. Okay. But it is just a visual effect. It is not showing anything else. Okay. Any confusion about this ROC-AUC?
Actually, yeah, I have a question. So the most important thing that we found out the true positive value. So why we are studying the negative, the false negative, the false positive, sorry, and the rest of them? Like, what's the more important thing for recall or?
Okay, so I will give you one example here. This is true for us because if we are talking about only the true positive, this is most important for us because we want to increase the value of true positive, which is actually positive, we get a positive, right? But we need to focus on the both errors. Why? Because in both cases, you have a binary, like when we are taking an example here, binary classification, you have a both kind of data. Let's take 100 records. In this, you have a 60 records of patient have a heart disease, 40 records patient does not have a heart disease. I want to predict my machine in both cases correctly, right? I want to reduce both. But my goal is to check, like, make my model like this way, my machine is able to predict correctly the true positive cases, right? But it is a machine. How we are like doing, preparing our model, we are selecting the data set, right? Doing the analysis. Whatever the machine is predicting, it depends upon the over analysis and modeling. In that case, we need to look at both type of errors. That's why, okay? Important is both, but our goal is always to predict the values correctly, which were actually positive. If your focus is only on that, like you want to reduce the false positive only, then you are going to talk about the precision, right? And if you are going to talk about only the things the machine is predicting correctly, positive value out of the total, we are talking about the recall in that case. It depends upon your situation, your business problem. Does it make sense?
Yeah. Thank you.
Okay.
So, I also have a question about the ROC curve. And I was wondering, is there a curve that kind of let's say, flips this idea on its head. So a curve that's looking at the false positive rate versus the false negative rate.
Okay, so what I understood from your question, like you are saying if false positive rate is here.
No, like, well, I guess so, but a rate, like if you're looking to, let's say, optimize your false negative rate, right? So I guess the example I'm thinking of would be like a military example. So like a stealth simulator, right? So you want to make sure that the stealth bomber can, you know, go through the radar without being detected. So if you have a lot of simulations, then you would, you know, you'd want to make sure that the stealth system works correctly by showing false negatives until it, you know, deploys its payload or whatever. So what sort of curve would you want for that sort of case, where you want to see that the technology that you're simulating gets a high rate of false negatives, but not because the model is bad, but because the technology is good?
Actually, the ROC curve is a work only between the true positive rate and false positive rate against. Okay. If you want to look at your false positive, right, or false negative, then we go with the confusion matrix. This is only like the ROC-AUC meant to be to see the rating between true positive and false positive. False positive rate. Did I answer your question, y'all?
So I get that. I'm just wondering if there's a different curve, like if there's a different type of curve that does what the ROC curve does, but for false positives and false negatives.
Okay. Yeah, in that case, what will happen if the false positive rate, if you draw, in that case, what will happen? This curve is going to be here. Okay. This is going to be something like this. Then in this case, what it will happen? It will, a ROC will show you, this is a poor performance model. This is a dumb model, according to ROC.
Okay, so I guess if I'm understanding correctly, then that sort of test case, you wouldn't use something like a ROC curve or like an opposite ROC curve. You would just use a confusion matrix.
Yes, in that case you can use, but if you are looking to like for the false positive rate, right, according to business problem, maybe for you the false positive is more important, right? In that case, if you draw your model is predicting the this class more correctly, right, more classifying rather than the true positive, in that case your ROC curve is going to be here. So it is going to be like dumb model. The curve in ROC, when it is above this line, then only we take it as a good model, right? But if it is going to be below your 50%, like this one, this is going to be bad model. Okay. So this is the difference, like how we look at the ROC-AUC curve, why we use it. We only visualizing the difference true positive rate against the false positive rate. Okay. So here in this diagram, we are showing the same thing, right? In this, we are saying, which I have already explained, if your true positive curve is not above 50%, it is only here. So this means your model learned nothing. It is a dumb model. Okay. Your curve should be above this 50%, your false positive rate. Then only we will consider it a good model. And if it touches here 100%, then it is the best model. Sometime you may get, but it's very difficult in real projects, real-time world like this. So that would be counted as your best model like this. Any questions till so far before I move ahead? Okay, take your time. This is the another very good example to understand your ROC-AUC curve based on the different distribution your classes like negative and positive. If you go here, you can see right now both you have a two classes negative and positive. So both classes have an equal distribution. You can see we have set the decision threshold value in the middle. This means 0.5. So your model was able to predict correctly the negative cases as well and positive as well, right? But if I start changing the value, look at this, right? It is also changing. So your model is not able to predict correctly the negative ones, right? If you go like this, look at the result. Your model did not predict any value of the negative. It is only predicting, say, it's all positive. So this is the dumb model. Okay. So this is the way how we can see. And the most important thing about the ROC curve is that it will show you the good result if your data is not like balanced. You have a normal distribution of the classes. With the same case, if you look at this, if you have an imbalanced data, let's suppose the data set something like this. So it's tough for you to decide the decision threshold value here, right? It will not work good in that sense. Okay, you can see where the curve is going, right? So this is not too good model. Does it make sense? Any questions? Okay, so this is a summary of the lesson. We have discussed today how to evaluate the model using threshold value without changing your model. Okay, and what is the purpose of ROC-AUC? Okay, now we will move ahead with your temperature check. But before that, I have a one poll for you. The greater the value for ROC-AUC, better the model. Is it true or false? Good. One more response is left. Its answer is true. Good. Because we have discussed higher is your true positive rate, best is the model, which is our goal, right? It is not like something you are doing with it. It's just a graphical representation of your predicting based on different your threshold value, how your model is look like. Okay. Now I have a one temperature check for all of you. It will help me how like much did you understand today from the lesson. Okay. So have a confusion in the precision and recall, we will discuss in office hours again. Okay, good, good, good. Thanks for your response. Okay, so let's move ahead with the code along. So today we are going, we have taken a heart disease example. Same example, we are going to take it here. First of all, you will import all libraries which is required. And then you are importing the train test split to split your data set. Logistic regression because we are considering the binary example here. Then we will import the standard scalar, one hot encoder, pipelines, make pipeline, compose column transformer, matrix, ROC curve, confusion matrix, precision recall display, ROC curve display, and your F1 score and classification report. Okay. So can anybody tell me what does the classification report contains? Anyone?
It contains the recall precision and accuracy, right? And the weighted
Yes.
averages as well.
Yes. Correct, Noor. Thanks for your answer. Okay. So now we will we will load the data set. This is your heart disease data set, right? So you have these features. So what is your target one? Heart disease in this, right? It's a binary one. Okay. In these, okay, I would like to tell you one thing more here. There is a very common mistake by the students. Okay. When you get a data set, if you look at this targets, sometime what happened, we look at the numbers, but we forgot it's a binary and we consider it as a regression problem. Okay. So you need to take care of this thing. Whenever you get a data set, look at the target carefully. Okay. If it's a 0, 1, or maybe 0, 1, 2, 3, 4, right? You may have a multi-classification, right? So don't take it as a regression. This is your classification problem. Okay. Which numbers are repeating many times, like if even it's a 0, 1, 2, 3, 4, and it's repeating, this is your multi-classification problem. And if it's a 0, 1, this is your binary classification, not regression. Okay. This is very common mistake. Okay. And now, first of all, we will make a copy. So because we don't want to touch the data set original, and then we will check the missing value. When we will check the missing value, you found there is a no missing value. Okay. Now we will check for the duplicates. There is a no duplicate, right? So can anybody tell me if value, which step I can skip? During analysis, before, like for the when we are doing the preparation for module.
Using the imputer?
Yes, Joshua, great answer. Right? We can skip those because we don't need that. Now what we will do here, we will drop the target, your feature from your X feature, and we will set the target one. Okay. And then we are just setting the labels. This will be useful when you are drawing the confusion matrix. Here, sorry, we will split the data set using train test split. XY random state is equals to 24. Okay. These are the steps I have found, which I discussed in the start of the lesson. Many students are repeating these steps for each model. Okay. That is incorrect. Don't repeat it for every model. We only going to do it one time because we are using same data set. We don't need to split it again and again. Okay. So this is the reason. If you do this in BELT exam, your marks will be deducted. Okay. Now we will do the make column selector in this. We will say, separate the object and numbers, right? In this case, I have a one question here. If in the categorical, you have a two type of data, ordinal and nominal. So what is the best way in that case to separate the categorical one? Are you going to use this one or no? How would you handle? Because to convert them into numeric, there is a different way. Anyone?
Manually?
Scalar?
Yes, Ahmed, correct answer. Great, manually, right? Because if you are using this method, it contains both type of your data together. What will happen? You are going to apply one hot encoding on both, right? Although there is a no harm in that, but it is going to be unnecessary, creating a lot of columns, right? Because one hot encode can like create your columns according to your different categories, right? So this is you need to take care. Okay. Does it make sense? Anybody have any confusion in this? It's very important for pre-processing. Okay. Now we will use make column transformer. So we are going to use one hot encoder for categorical selection. Standard scalar for numerical. Why we use the standard scalar for numeric data? Why I don't use for this one? Why I need to scale it? Anyone?
To minimize the numbers.
So no
Minimize.
one, oh, sorry.
Yeah, go ahead, Namnoor.
So no one column has more weight over the others.
Yes, right. Amal, you were
Easier,
also right.
easier to process.
Yes, right. Because sometimes what happens, your different column have a different magnitudes, right? We want them all in the same units. So your model cannot be biased. Maybe your model don't think, oh, this is a high value, so I will give the weightage to this one. Okay. So that's why we use the standard scalar to scale your data. Okay. Can we scale ordinal data? Is it good idea?
Typically not, unless you have a lot of ordinal data.
Yes, great answer. Yes. Now we will declare the instance of logistic regression. Okay, we are done with checking the duplicates, missing value. We have separated the object and numeric data. We make the pipeline, one hot encoder to convert your categorical into numeric. And we also added your standard scalar to scale your numeric data. We are done with the pre-processing steps. Now it's time to be model it, right? So we will declare the first instance of your logistic regression. We will make a pipeline. Here, you can directly pass the preprocessor. Okay. Where is the preprocessor? This one. So preprocessor contains your all steps. Okay. Here is a one more mistake I have seen, like in assignment. After preprocessing, what we are doing, we are here doing like this, fit X string. You are doing it for X test, you are fitting it again, you are transforming the data, right? And then you are declaring the model, again, pre-processing it. Okay, so you don't need to do that. That was only in case if you are not using the model. This means you are you are transforming the data 2 times. Okay, which is not required. This is an extra piece of code. Okay, this is not required at all. You can directly use a preprocessor. It contains your all preprocessing steps and then pass the instance. You will make a pipeline, fit onto X train, Y train, and then you will predict as we do. One for your train data, other for your test data. Okay. So now look at this. Here I am using the predict one. Right? We use it earlier as well. Look at the output. It's a 0-1 form, binary form, right? But if you go down, okay, so this is, first of all, we will discuss this. Then we will use a classification report. In this classification report, it is showing you the precision, recall, F1 score, and sport, right? So what is the advantage of classification report? It contains the result for each thing, each value, precision, recall, F1 score under one roof, right? If you don't want to use a precision, recall, F1 score separately, you can use a classification report, okay? But don't forget to use confusion matrix, okay? This is very important. So in this, you can see note, no heart disease precision is 87%, right? And heart disease 85% in this case, right? And what about the accuracy? 86%, 85%, and 86% in this case, right? So now, if you look at the confusion matrix here, disease and your no heart disease. So these are your good numbers, right? And these are your bad numbers, right? So this is a result showing you according to the predict method, right? Now look at the different way. Here, I am using predict underscore proba instead of predict. This is why we are using, because it is giving you the probability of each data point. If it's happening, it is going to be predict 1 or 0. This means each data point, your machine is saying the patient have a heart disease, the probability of that is this much percentage. Okay, it's not going to be 0, 1. It's going to be in the form of percentage in this case when you are using the predict proba. Because now I want to use a decision threshold cutoff. That's why in this case, you are going to use predict underscore proba. Okay, not predict. Now look at this result. What is the difference? Above, it was showing in this form, 0, 1, right? For each data point. Now look at this result. First column we will consider as a 0. Second column we will consider as a 1. Okay. So at a first data point, your machine is saying 0.08% of the probability of happening patient does not have a heart disease. Okay. But 91% chances patient have a heart disease. It is beneficial in case of percentage because your machine is not saying the straightforward 0, 1. The chances of your classifying the class correctly is increasing in this case because you are getting the percentage, right? Again, if you look at these, the result matching, the first data point is saying 1, right? 91%. So look at this result. It is also 1 here, right? And if you look at the rest of the results, higher the percentage of your 1 value, 1 prediction. It's a 72%, 0.27%. So I am going to consider the higher percentage, right? 76%, 98%, and it's a 0.05%, right? 94% patient does not have a heart disease, right? If you match it above, it's a 0, right? So this is the difference between predict and predict proba. Does it make sense?
Yes.
Okay, good. So now we will talk about the decision threshold value. First of all, you can set 0.3, 0.5, 0.1. This is your choice. Okay. So in this, we are using a lambda expression. This one. Okay, sorry, list comprehension. So in list comprehension, we are setting up 1. This is for conditional. If x of 1, x, why we are considering it as a x of 1? Because I want to take this value. Okay, as we have discussed in the slide, if my given value is greater than threshold value, it should consider it as a 1. Otherwise, it should consider as a 0, right? So if it is a greater than 0.30, we are saying patient have a heart disease. If it is a less than 0.30, we are saying no, patient does not have a heart disease, right? So This is the one. So we are using list comprehension here, greater than threshold value, else 0, right? For X in train props. One loop we will run for training data points, other loop we will run for testing. Okay. Now look at the result. Okay. So you can keep on changing the value. Let me run only one time. If you want, you can changing the values and see the difference, how much big difference it is making with the 0.5, or is it making or not. No, it's not making any big difference. Okay. So you can try how you can look at this. Now what we will do here, this is the result with the confusion matrix. Whenever you are doing the classification modeling, don't forget to use confusion matrix. This is the only matrix which is going to give you the clear picture. How many false positive, how many false negative errors you have. So now look at this confusion matrix display from prediction y-test, test predictions, right? This is your actual value. This is predicted value. Normalize is equals to true. Display labels. This is we have created earlier. This one, if you remember. Here, right? So we are using here. One value we are drawing the confusion matrix with the decision threshold value 0.5, one is 0.3. Can anybody tell me which confusion matrix seems to be better for you? And you can also interpret it. How do you interpret the confusion matrix? Anyone? If we want to interpret this confusion matrix, how would you
0.5.
interpret? Sorry, can you repeat? Anybody? Can anybody interpret the result by looking at the confusion matrix? Okay, so these are your good numbers, right? 90% of your model is able to predict patient have a heart disease. This is good, right? And your this error is low, right? If it's a 1, it's saying 0, right? It's a 1, right? So it's a false negative, right? And here, what is this? False positive, right? So in this, if we want to decrease it, right? Now look at this decision threshold value 0.3. This is increased, right? From 0.9, it increased to 0.94, right? And this is also decreased, right? So which value would you consider, 0.3 or 0.5?
I think that they're both kind of have sort of inversely related positives and negatives. You know, I mean, it's I don't know if either
Yes.
one's better than the other.
Yes. So Sam, in this case, like if false negative is very important for you, more expensive, then you are going to consider this one, right? Because your this rate is increased with the 0.3. If you want to balance both, you can try some other threshold value, right? You don't want any patient to be go unnecessary under the further treatment, which is not, which does not have a heart disease. You also don't want any person to left which have a heart disease. This means you want to balance both, right? So you can try with the other threshold value if you want. Okay. Now we will loop over the different threshold value. How would you do that? You can use a numpy array to set a range. Okay. This is a range we are setting 0 to 5, right? And then we are dividing it with the 100 because I want it in the percentage form. Okay. So now look at the loop. for threshold value. Okay. And then we will set the here values as we did above. And then we will plot a graph. Okay. So this is showing you the train accuracy, test accuracy against with the different decision threshold value. Right? So if you look at only, let's look at first the train one, right? So if we try to interpret this graph, this seems to be higher value, right? And in case of test, this seems to be more good value, right? So here the accuracy is high, right? We cannot, we can just interpret the graph like this way, okay? In BELT exam as well, you need to interpret the confusion matrix as well, okay? Don't only write one line. The true positive value is 90%. This is false negative is 0.06%, right? This is we can see in the picture, right? But you need to say it as example, as I have a heart disease business problem. For me, the false negative error is most expensive. That's why I'm choosing this threshold value, because it is reducing my this error. I don't want to like the patient left untreated if he has a heart disease. Okay. This way you need to interpret the result for confusion matrix. This is very important. Okay. And now we will move ahead. So now look at the scores. We will sort it ascending false. So 0.6 threshold value seems to be best. Okay. So we are going to consider this. And then now look at the ROC curve. Okay. So what is a ROC curve? Here, this is covering your, showing the true positive rate against your false positive rate, right? Your maximum area under curve is larger, right? It is above your this baseline model, right? So good is the model, higher is the curve, best is the model. If we look at this point, this one, this is going to be good, right? So this is your ROC, which is displaying you the result against the test one. Okay, test points. And now, if you want to creating an evaluate function, we will create here evaluate function classification, right? Under this, we have a confusion matrix, your classification report, and ROC curve display. 3 matrix we are using together under custom function, right? So in this, look at the result now, right? So this is a way how you can use them combined, okay? Using the custom function. Earlier, we were doing it separately, but you can make a custom function and combine it under one roof. This is the best way to write a repeated code again and again for each model. This is the best way to make a custom function. Okay. So now this is for training data and this is for your test data. Okay. This is the same for this one. Okay. So now this is a challenge for all of you. Okay. Evaluate over model using over function with the test data, because we are doing with the training, and use the function twice to evaluate over model on training and test, right? And here we are using different models as well. Random forest classifier, XGB classifier. Earlier we were using logistic regression, K nearest neighbor classifier. Okay. So I have used only the random forest classifier here. Now look at the graph. It seems to be same, right? In logistic regression, it was also showing 90%, right? And now look at the K nearest neighbor. This one, 94. So this is working more better than this one, right? So now you can also do with the XG boost and see what is happening. Okay. There is a no compulsion. Who want to stay, they can. I will open the breakout room if they want to test it. Okay. Okay, so now let's discuss about the precision recall curve. Okay, so what is the precision? Anybody? This is a graphical representation. We are looking at the precision versus recall. Visualizing, earlier you were talking about the numbers, right? When you are using the classification report. Now we are looking at it visually. Can anybody tell me what is the precision and recall here? Now look at the values. I will give you the hint. Your recall value is a starting percentage from 0 to 100% here. And this is your precision. Right? Is this high precision or high recall graph or any other combination?
It looks like a high precision and recall graph.
Yes, Namnoor, great answer. Yes, because your recall is 100%, right? So this means your model was able to predict the total, your positive prediction out of the total positive classes, right? In precision, precision is also higher because your model was correctly predicted the actual positive classes. Okay, both are high in this case, right? It is representing in this case, right? This is your true positive rate is very high because your precision and recall both are high, right? So now, if we move ahead, right? In this, which to use, ROC curve or precision recall curve? Okay. This is overall your ROC curve display is better option to use in most situations because it is giving you the rating between true positive rate and false positive rate, right? But if you want, you can also use your precision, your precision recall curve as well. It depends upon you. Both are doing the things, but our main goal is to look at the true positive rate. So in most cases, we use ROC-AUC. Okay. So this is the difference between your ROC-AUC and precision recall. You can use both if you want. But this is just a graphical representation. You are not doing any manipulation here, right? Whatever you are getting the result, you are looking at it graphically. So you can understand it better instead of only looking at the numbers of the precision and recall. Okay. And any questions still so far? All right. Okay, I will repeat the definition of precision and recall if there is any confusion between precision and recall. Okay. In this, okay, first of all, tell me the definition of precision. Anyone? So I will stop